Special thanks goes to Gunnar T. Bivens, aka Sauropod King or Brick Smash TV on DeviantArt. He was instrumental in the creation of this episode and is the writer, so go check out his scientific paper and his DeviantArt, link in the description. Thanks, Gunnar! When we look back through time, we see many avenues of evolution that we consider strange, for we do not tend to see such things in our day-to-day lives. However, strange is what life is all about. Trying new things, getting to know the environment, striving to reach the top rungs of the jungle gym of life. The Mesozoic and all the different forms of dinosaurs were no different. And they produced their fair share of oddities, one of which had a spectacular protrusion from its neck. The bitter reptile from La Amarga, Amargasaurus. During the early Cretaceous, the planet was teeming with all sorts of weird animals. And not only was South America no exception, it was host to bounties of strange animals seen nowhere else in the world due to its isolated nature at the time. You've got anything from sauropods with ankylosaur armor, giant allosauroids that hunted the largest animals to ever walk the planet, to even short-muzzled theropods that looked like their faces were smashed by a car. At this point in time, titanosauriforms were fast becoming the dominant group of sauropods on the planet. But down in Gondwana, diplodocus still held some ground, with the early Cretaceous of Argentina hosting the last of the diplodokids, Linecupa laticata, and the extremely derived grazing Rabachisaurus. One group distinct from these was the dicraeosaurs, a group of small diplodocoids most well known by their uncharacteristically short necks and small size. This group included the extremely short-necked Brachytrachelopon and the somewhat controversial Morrison species Suacia. Amargasaurus is known by only one specimen, with no subsequent finds having ever been found to date. It's a good thing that one find is very complete, so complete in fact that it included a partial skull, the neck, back, hip, and tail vertebrae, pieces of the arms and legs, and parts of the hips. Found in 1984 by Guillermo Ruggier, Amargasaurus was discovered as part of the Jurassic and Cretaceous terrestrial vertebrates of South America project funded by the National Geographic Society in 1975, as well as other well-known, mostly complete, but single specimen Carnotaurus. The remains of Amargasaurus found were quite remarkable for many reasons. Amargasaurus stands out from the other members of its family, as well as most sauropods in general, quite obviously, due to the long, extended spines delicately erupting out from its broad neck. These spines start at the very first neck vertebrae and don't technically stop till near the halfway point of the tail. The neck spines are what is considered bifurcated, which really just means that there were two of them side by side, symmetrically aligned. They also bend backwards over the vertebrae behind it and end in rounded tips. As you go down the neck and trunk of the animal's body, you see that the spines shrink and become placed closer together until it reaches the first couple of vertebrae after the hip vertebrae, at which point a new type of neural spine replaces the fragile, thin spikes of the neck. The neck spines are replaced with a paddle-shaped projection of the vertebrae, creating a ridge going down the animal's back towards the end of the tail. There has been a debate over whether or not the spines were covered in a row of thin skin, or if they were open and covered in keratin instead. Those who advocate a covering of skin note the texture of the spines is similar to that of sail-backed Pelagosaurs, like Dimetrodon. Most others are against this hypothesis, though, noting that a sail covering on the neck would have reduced flexibility, and that animals that have sails in today's world, as well as those prehistoric animals that must have had a sail, have broad, flattened neural spines, while Amargasaurus has thin, pointy ones. Some have suggested the spines could be used in a combative role, defending against predators, or as display to members of the same species, whether covered in skin or not. The spines of the neck taper towards their end, which means that they are pointy, like really pointy, being wider at the base and thinner at the tip, which is weird for something that would only be used for display, as display-only structures tend to be wide and flat to help increase surface area and therefore act as a better display. The keratinous coverings of the spines was originally hypothesized by Leonardo Salgado in 1999. Evidence for the covering of keratin was shown in the striation of the bone of the spines, which may be analogous to the horn cores of modern bovid animals, who have also had a keratinous sheath covering their bony projections. The use of the spines as display has been discussed many times, but how it did so we have yet to cover. It is possible the animal could have bent its head and neck all the way down to the ground, spreading the spines forward, making even the smartest of predators think twice, while also keeping the head away from the biting height of most theropods of the time. We suggested that if the neck had skin or muscle stretched between and through the spines, the neck would be immobile. However, skin can be incredibly stretchy, so much so that it is also possible that it had a skin sail that could stretch to allow the animal to move its neck. Thus, it would not be immobile. So at this point, either goes, but we consider the bare keratinous spines to be more likely. Mark Hallett and Matthew Waddell suggest the animal may have been able to use its neck spines as a way to keep predators off its back. The neck has the ability to be more or less flexible to certain degrees, and if the spines were covered in keratin in life, then when a predator pounced on its back, it could snap its neck backwards and skewer the attacking predator with its spines. Kind of a nasty self-defense move, which would make it kind of like a dinosaurian porcupine. This defense mechanism isn't out of nowhere either, since the modern giant sable antelope and Arabian oryx use this to keep predators away. And they have the same kind of striations on the bone core that corresponds to the keratin sheath that is then hypothesized to be on the Amargasaurus. And yet, the tale becomes even more bizarre. In 2007, Daniela Schwartz et al. Found that dicraeosaurids and diplodocids had a system of enclosed air sacs within the spine of their vertebrae that were attached to their lungs as part of the respiratory system that helped such large animals breathe and move more efficiently. This means that Amargasaurus would have had such a system as well, but since the upper 2/3 of the spines were covered in some kind of hard material, the air sacs would have been restricted to the space between the spines below this level of sheath covering. Another reason as to why this find is unusual among sauropods is the preservation of part of the skull. See, with sauropods, you got yourself an animal whose remains do not like the fossilization process. The animals were made up of hollow suspension bean-like bones of incredible size, topped with a proportionally incredibly small head. When such massive animals die, they are usually the feeding grounds for tons of animals, just as dead whales are to the critters of the ocean. Therefore, there are many environmental things that can tear apart a sauropod carcass and scatter every single piece to the farthest reaches of the land. This process means that nearly all sauropod species do not have preserved skulls. We only know the shape of the skulls of some of the sauropods due to finding more than one of the same animal, and even that is 1 in a million chance. Which is where we come back to Amargasaurus. The remains of Amargasaurus included a partial skull. Since we have the basic idea of the skull shape of diplodocids as well as the dicraeosaurids, we can accurately judge the basic shape of the entire skull of Amargasaurus. Its skull was long and thin like a horse, but the end of the snout got bigger at the end with a rounded tip, the better for biting through foliage, stripping it of its leaves with its long, peg-like teeth. Like many late Cretaceous sauropods, this magnificent find was made in Argentina. Specifically, the specimen comes from La Amarga Formation of the La Amarga Arroyo in the Picún-Letú department of Nequian province in the northern part of the Patagonian region. The rocks it was found in, part of the La Amarga Foundation, radiometrically date to approximately 130 to 120 million years ago, which means that Amargasaurus also comes from this time, the Barremian and Aptian stages of the early Cretaceous. Amargasaurus lived with many other animals, especially sauropods, who suggest it had a different niche to all the other contemporary sauropods, which included Zapalosaurus and Amargatitanus. Since Amargasaurus had a neck length intermediary between the shorter neck of Zapalosaurus, which fed at ground level, and the Titanosauriforms, which were higher browsers, Amargasaurus would therefore have fed above ground level. It also lived with animals all creatively named after the exact same place, including Amargastegos and Amargasuchus, but also Liga Bueno and Vincelestes. Amargasaurus was the last of its kind. The diplodocids themselves disappeared very early in the Cretaceous, with Linecupal and a few unnamed Gondwanan taxa. It is unknown why dicraeosaurids and diplodocids died off. Perhaps the rapid proliferation of the highly specialized Rabachisaurids, as well as the increasing diversity of Titanosauriforms, eventually led to a lack of niches for these families to fill, and they were left to fade out of existence, gone but not forgotten.